do you say Papa? Is that what it is?
Yeah.
I forgot to start it initially, but we went over kind of the homework and what we did. The only one we haven't done is 7. So what did you guys get when you randomly took, so there was a sample, a test size. They got that, those particular numbers of income, right? If you look at number 7 on the homework. And then we each randomly took information and figured out a mean and figured out a sample mean. What sample mean did you guys get?
Randomly selected.
Let's see, number 7. Let me back over here to content. I think my internet's being slow. That's the only thing I wanted to see is what if this whole thing acted like it was supposed to. Go to homework. Okay, so if you, it's like this little graph of, what the heck was that? It has this little graph of numbers, and then you're supposed to like randomly just pick 5 out of those 30, and then we're supposed to each plot it until we see where it's at. What is that? Is that one? Anyways, I got 4,800, which is slightly off from center when I randomly just picked it. So they said it kind of fell into that 68. And whatever. I was just curious what your guys' answers came up with on 7. But let's go to the quiz and talk it through. Did anybody do that one on the homework?
No.
That's okay. All right. And then I'll go back. Let's just go to the quiz and go through it and see if we can just, we can talk through it as we dig through the questions. All right, homework group meeting quiz. Okay. Okay, let's start with number 3 for lesson 6 group meeting quiz. It says, when you are taking a sample size of n, so 5 people, or 5 answers, or 5 bits of data, what is the shape of the distribution of means? Histogram, when the parent population is skewed right.
It'll be skewed right as well.
I got skewed right. Skewed right.
Skewed right. Okay.
Yeah.
When you are taking a sample size of 100, what is the shape of the distribution means, histogram, when the parent population is skewed? Right skewed.
Be normal.
Normal. Because there's some rule of thumb that says as long as it's greater than 30, when you do it, it will always make a normal histogram, no matter what the parent or the raw data look like initially. But if it's less than 30, then it probably will look like its parent. Okay, number 5. When you are taking the sample size, number 5, what is the shape of the distribution of means histogram when the parent population is normally distributed?
Normal.
Normal. Okay. Number 6, when you are taking a sample size of n, that's 100, what is the shape of the distribution of means histogram when the parent population is normally distributed? What is with these questions? It seems like Way too easy. Like,
I- Norm.
Norm. When would the distribution of means be normally distributed? And I think this is the laws or the two rules. When data is drawn from the population that is normally distributed and the sample size is small. Data are drawn from a population that is normally distributed and the sample size is large.
When
Data, which one?
normally distributed.
I got 1,
And
2, and 4.
I think 2 and 4. That's what I'm thinking.
And 1, 2.
I did.
It's true, because as long as it's normal, then it's going to be normal.
Data are drawn from a population that is normally distributed. The size is small.
Let me see if I can find this. Okay. Normal distribution. If the raw data is normal, even if you use a small number, it's going to be normal. If raw data has outliners or is strongly skewed, then you need to have a greater. Great. Okay. I think 1, 2, and 3. I think.
Okay.
Okay. Which of the following gives the best explanation of central limit theorem?
I got the third one.
Third one. I agree. That's all it says. That doesn't say anything else. It just says there will be. Well, no. Hold on, because there's something about that.
Yeah, I think it's the 4th one. If you look up the
Yeah, the definition is.
like the definition or whatever that is, like it talks about that the number 4.
Because because most people mess it up. The distribution sample means, okay, the distribution sample means normal when X is normally distributed.
Large.
Or when our sample size is large. Distribution of sample means is normal when sample mean
A pressure as the sample size gets larger, no matter the shape of the population distribution. The fact holds especially true for the sample size over 30. All this is saying that is if you take more samples, especially large ones, your graph of the same sample mean will look like a normal distribution. I think it's the last one. Yeah, because it's not the second one.
It's not the second one. I feel like the rule of the, there's one that says most students get this confused. Let me see if I can find it. The law of large numbers. Take a moment to study the difference. They are different, but students tend to confuse them. Okay. The law of large numbers states that the mean, sample mean will be close to the parent population. You're right. Okay, so we're talking about the central limit theorem just says normal size. Law of numbers says the means will be the same. Is that what you're getting out of it?
I think it's the last. You think it's the third?
I thought it was the third.
100% positive.
The shape of the distribution. I think it's the last one. I think it's number 4.
I think it's the last one too. I'll go with the last one.
Me too. Okay.
Because the large number just says that the means, both means will be the same, large number law. And whereas the central talks about normal approximate size. So I'm going with 4. Okay. Using this information, what is the mean of the distribution of sample means? 10, right?
Yeah.
Because it's the same thing.
Uh-huh.
Okay, 10.
Yeah.
What is the standard deviation of the distribution of the sample mean? So this is the one where we need to go the square root of 36, right?
1.
X divided by 6, yep, would be 1.
I say 10.
On 10?
I got 1.
I got
Wait.
1.
I got 1. For number 10, right?
On number 10.
Yeah.
Yeah, I got 1.
Mm-hmm.
Everyone agree 1?
Yeah.
Okay. Question 11. Regardless of the distribution of the population, the sample size is large and is greater than 30.
Mhm.
What would the shape distribution of the sample mean? So it's going to be normal. You agree with that?
Yeah.
Okay. Number 12. What theorem would justify your response to the last question? And I would say central limit theorem.
Yeah.
I agree.
Okay.
Okay.
Let's submit it.
Okay. I'm scared.
We got it. Okay. Anybody have any questions?
I was just wondering if you guys okay with meeting on a different time on this Thursday, like either at 6 o'clock or like 9 o'clock.
Oh, in 2 days? I don't care either one. I can
Coming-
do either one.
So
I work at 7.
1 o'clock might be easier.
wait, so
I work
even-
until 7, but I can't guarantee that I could do that this late because I'm moving. So I'm packing as soon as the meeting's done.
can you do it? So you're working at 7? Can you like do it at 6?
No, I work until 7.
Oh,
So
you work at
9 p.m. would be better.
9 o'clock.
But I wouldn't be able to do a long one because I'm getting ready to move this Friday.
I think we could do it pretty quick. I think because this
I
one,
mean, this one only
it's 25 minutes and we're done.
Okay, yeah.
So
So we're gonna do it at
this
9.
one's 9 p.m.
Okay. That's awesome.
and we'll try to keep it short. We'll just try to straight to the point and get it done. And okay.
Yeah.
Okay. All right. I'm gonna stop the podcast and
Perfect.
end this and